In this question, we're asked to determine the empirical formula and the name of several compounds. So, in the first case, we have Pb2 plus and Br minus. We cross the charges and we get PbBr2. So we bring the numbers down, but not the plus or the minus. They're not subscripted here. And since this is just a 1, we don't write it here, and we also don't write it here. So we cross the numbers, and we get PbBr2. Now we need to name this. When you're naming compounds, first you have to decide whether they're covalent or ionic. And you may have seen this before in another video, but I do want to bring out this flowchart again. So the first thing we want to know is, does the compound contain a metal or polyatomic cation, a positively charged polyatomic ion, such as NH4+. In this case, the answer is yes, it contains lead. Lead is a metal, so we know that it's an ionic compound. However, before we can name it, we want to ask ourselves one other question. Is the metal capable of forming multiple charges? And then it says, generally transition metals and metals under the nonmetals on the periodic table. So if we find lead on our periodic table, lead is right here underneath carbon, and it is capable of forming multiple charges. So we want to select yes here. So to name it, we want to name the metal, then the nonmetal ending in "ide," or the polyatomic ion, but we don't have a polyatomic ion here. And then it says, use a Roman numeral to indicate the charge on the metal. So when we name this, we do need to use a Roman numeral. So in this case, we want to call this lead 2 bromide, where 2, the Roman numeral, tells us the 2+ charge on lead. In the next example, we have Pb4 plus and Br minus. We cross them, and we get PbBr4. This would be the empirical formula, which would go here. We now want to name this, and this is called lead 4 bromide, since it's still lead, and lead is capable of forming multiple charges, which big hint here is that this is 2+ and this is 4+, so there's multiple charges in this individual question, so it's certainly capable of forming multiple charges. Then you want to use the Roman numeral in the naming. Next we have cesium and bromine. So we have Cs plus and Br minus. We cross the charges and we get CsBr. Now we want to name it. So I'm going to go back to our flowchart. Does the compound contain a metal or polyatomic ion? A polyatomic cation. So the answer to that is yes. So therefore it's an ionic compound because it contains a metal. Is the metal capable of forming multiple charges? And again, that's generally the transition metals or the metals under the nonmetals on the periodic table. The answer this time is no, because cesium is a main group metal. Remember, these are the transition metals in this area over here, and cesium is right here on the periodic table, so it's a main group metal. So here the answer is no. Name the metal, then name the nonmetal ending in "ide" or the polyatomic ion. We don't have a polyatomic ion here, so we don't have to worry about that. So we just name the metal, cesium, then name the nonmetal ending in "ide," bromide. The final one that we want to do is barium 2+ and Br minus. So Ba 2+, Br minus, cross the charges, Ba Br2. Again, we want to check to see if barium is capable of forming multiple charges. We find that barium is also a main group element, so it's not capable of forming multiple charges. So we do not need a Roman numeral. So we just call this barium bromide.